Okay, section 1.5, we're going to solve some equations and we're going to have the best time doing it. So I'm just going to try to give you an example of every different thing you're going to see as we go through this class, and you'll see on your homework. If I encounter anything that you don't remember, then ask for a little explanation. But my assumption is you've seen this an infinite number of times. So we're going to solve example 1 together. I'm going to write all the steps the first couple of times, but I'm assuming you're college algebra students and I don't need to write every step. If that's a bad assumption, let me know. So when I see this problem right here, what's the first thing I ought to tackle on this? Yeah, let's go ahead and simplify it a little bit. And what you've said is great. Let's take care of those parentheses. Let's distribute. So I'm going to do that. So I have 10 plus 3 times 2 is 6x. 3 times -4 is -12. On the other side, I have that negative, and negative times a positive x is -x. A negative times a positive 5 is -5. Great. Step 1 done. I've not solved anything. I'm trying to make this look more palatable to start with. What's step 2? What should I do now? Yeah, let's get those like terms together. I don't need all those extra terms to deal with. So on the left, what are my like terms on the left of this problem? Yeah, the 10 and the -12. So I have 6x, and 10 minus 12 is -2. And on the right side of this, what are my like terms? Yeah, the 17 and the -5. So I have -x, and 17 minus 5 is +12. Just a note, you can have the terms in a different order. If you have -2 plus 6x, or if you have 12 minus x, that is totally fine. Miss Hilliard, when I was in 10th grade, demanded the x's first. So I've just kind of been trained. So that's what I always do. Another thing Miss Hilliard always trained me to do is x's on the left. So that's what I tend to do, but you could put the x's on the right if you want to. You're going to get the same answer I'm going to get. But if I want to get my x's on the left, what do I need to move on this equation? The x. How am I going to move this x? Yeah, remember, to solve linear equations, you're just always doing the reverse process. So this is a -x, so I'm going to add the x. And just to save a little space, I'm going to do both of these steps all on one line. Since I've moved the x to the left, what else do I have to move? I got to move the 2 to the right. Yes. So just again, a note. I'm not going to always make these notes, but if you had moved the 6x over to the right, then you are moving the 12 to the left. The goal is to get these two things on the opposite sides of the equal sign. That makes sense? Okay, again, I'm sure you've seen this. If you need more review of this than I'm giving you, then just see me after class. I got a ton of videos. Okay, no problem. So 6x plus x, that is 7x. My equal sign stays in the middle. My 12 plus 2 is 14. And then last but not least, what is almost always my last step on these problems? Divide. Yeah, fantastic. I'm going to divide by 7 here, and then 7's cancel, and I have x is equal to 14 divided by 7. That becomes 2. I am a little more fussy on this than I am in intermediate algebra. When I grade it, our solution is a solution set. Okay, we'll have equations as we go through this class that have more than one answer. Okay, so we want to write a set. So I'm just going to now throw some braces around that. And there we go. My solution set is the set with 2 in it. All right, I'm going to set you free to do exercise 1. If anything's not clear, wave your hand. I will come and try to answer as quick as I can to you. And we'll see if we can't make this all nice and smooth. All right, so I'm going to get started. If you're still working, keep working. Nothing wrong with you. We just all work at different paces, and that's fine. So first thing I'm going to do, just like on the last problem, is I'm going to get rid of those parentheses by distributing. So I have a -8 minus 3x plus 5. Notice that 5's not in parentheses, so I don't distribute anything to it. Then 2x plus 3. I do have some like terms there, not a whole lot of like terms. So on the left, I've got -3x, and then -8 plus 5 is -3. So far, we so good? Anybody struggling with that? All right, then I'm going to just put my x's on the left, numbers on the right. Again, you're free to do the opposite. We will meet up with the exact same answer, okay? If you get anything different than I do, then one of us did something wrong. Okay, so here we go. I'm going to subtract the 2x from both sides. And then I'm going to take that 3 and I'm going to add the 3. So -3x and -2x is -5x. The equal sign stays in the middle. 3 plus 3 is 6. And when I divide both sides by -5, well, this one's a fraction. That's okay. Fractions are legal. And so what I get here is x is equal to a positive divided by a negative is a negative. And I'm just going to leave it 6/5. If you have a terminating decimal like this one and you wanted to write 1.2, that's fine too. Okay, so, but we always go with exact answers. So make sure that your answer is exact. Still doing okay? All right, well, I mean, that's solving an equation. There's not really much more to say about it. I've put everything in those two problems that you're going to encounter. Distributing, like terms, moving the x's, and then dividing. I wanted to cover, I'm going to do example 2, and then I've got 2 examples for you just because this, I know, we've got fractions. Everybody's heartbeat is now going faster. Your blood pressure is going through the roof because you have fractions. So I just want to make sure that we develop a comfort level because all of unit 3 is going to be about fractions and rational functions and things like that. Okay, so here's what I want to do. Here's what you want to do. I don't want to have any more fractions. So I want to get rid of the 6 and I want to get rid of the 2. Does anyone remember the process for doing that? I'm going to multiply by what? The common denominator. Yeah. And it doesn't even have to be the lowest. If you don't like to worry about the lowest, you can just go ahead and multiply the 6 and the 2 and get 12 and use that. Your numbers will be a little bigger than mine. We'll end up in the same place. But the lowest common multiple here is 6. If you don't know how to find the least common multiple, that's fine. See me after class. I've got 2 processes that are fairly reasonable to do. Okay, so I'll help you out with that. But what I'm going to do is I'm going to multiply every one of these terms by 6. So 6 times the first fraction. I need to squeeze this in here. Sorry for the mess. I'm going to multiply the second fraction by 6. And then even though it's not a fraction, don't forget to multiply the -4 by 6. Okay, you can't change your equation by leaving that part out. So I've multiplied every term by the common denominator, the least common denominator of 6. Now what happens with my first fraction? When I multiply 6 times x plus 7/6, what happens with the 6's? They cancel out, which is exactly what I want. I should not have any more denominators when I do this. Okay, if you still have a denominator, you've done something wrong. And that's okay, probably easy to fix. And so when I do this, I just have x plus 7. Did I lose anybody? Still tracking with me there? All right, the second fraction, I've got 2x minus 8/2, and I'm multiplying by 6. What happens to the 6 and the 2? They cancel out. What am I left with? 3. Yeah, thank you. So the 2 goes into the 6 and leaves 3. So now, again, I don't have any denominator. That's what I wanted. What do I do with this 3 and the stuff that's already there? You distribute. Yeah, you multiply it. So I've got plus 3 times 2 is 6x. 3 times -8 is -24. On the other side of the equation, -4 times 6 is -24. That's the hard part. Once you've done that, though, this is just an equation like you're used to solving. And we're going to get all the x's on one side, all the numbers on the other side, and then we'll divide. Same thing every time. So the x plus the 6x, that gives me 7. The 7 minus 24 is -17. That's all my like terms, so I have no more like terms to deal with. All of my x's on this one are already on the same side, so that's good news for me. So what I'm going to do is I'm going to add that 17 to both sides. So the 17s cancel, and I have 7x. My equal sign's in the middle. Negative 24 plus 17 is negative 7, and we're just about done. The rest of this, I divide by 7, whee, and I get my x values negative 1. And there's my solution set. All right, if you have any questions about that, please let me know. If not, go ahead, exercise 2. It's pretty much the same thing, just different numbers, so that you can run through the steps. Just to give everybody a nudge, what's the lowest common denominator you're multiplying all 3 terms by? 12. 12 would be the lowest, but if you use 24, I mean, you can, you're just gonna have larger numbers. Okay, your answer will be the same. So you're multiplying each one of these 3 fractions by 12. I'm gonna give you about another minute to make as much progress on this as you can. All right, so I'm going to get started. Check your work with my work. If you're still working, keep working, finish up. So we already determined we're multiplying each fraction by 12. So this first fraction, 3 goes into 12 and leaves 4. So notice I don't have any more denominator. That's always my goal. So 4 times 2x is 8x. 4 times 1 is 4. The next one, 4 goes into 12 and leaves 3. Again, no denominator. 3 times x is 3x. 3 times negative 1 is negative 3. On the other side, 2 goes into 12 6 times. And 6 times 13 is 78. That's the difficult step. I think to me, that's the most difficult part of the problem. The rest of this is pretty standard stuff. I'm going to collect those like terms now. 8 and 3 is 11x. 4 minus 3 is positive 1. Just for room's sake, I'm not going to write down all the steps. I'll verbalize them for you. My x's are already on the same side, so that means I got to get the numbers on the other side. So I've got to subtract this 1 from both sides. And when I subtract the 1 from both sides, what's left on the right? 77. So now I have 11x equals 77. I've got to divide by 11. And when I divide by 11, what do I have on the right? 7. There's my solution. The solution is 7. All right, I'd like you to do the next exercise. It's another fraction problem. The reason I've got it on here is the terms are just written differently. Instead of stacking the expression on top of the denominator, I've got the fraction out in front. But it doesn't change the process at all. Step number one is you're going to find the common denominator of the three fractional terms and get rid of the fractions. Okay, there's three terms here, just like the previous problem. So your process is going to be pretty much the same. So I'm going to give you a minute to get started and at least identify the common denominator, and we'll talk about that. So I have my three fractions. I've got three denominators. What is the least common denominator of those three fractions? Yeah, 15 for sure. So if you got that, good. If you used, if you used 75 because you just multiplied them all together, that would work out. Okay, but that's gonna be a little more cumbersome. So 15 is the least common multiple. So I'm gonna give you about another minute. Make as much progress as you can on this. So what you're going to do now is you're going to get rid of the denominator of those fractions, and then on two of them, you'll have to distribute afterward. But get rid of the fractions first and then distribute. All right, so here goes. Check out your busy work with mine. If you struggle with this, we can talk about it when class ends, because I would like to get each of us through one more exercise, and that will be exactly where we need to be. So 3 goes into 15 5 times. No more denominator. So now outside the parentheses, 5 times 7 is 35. So I'll write that down, times 2x minus 1. I'm going to have to distribute that. Then I have an equal sign. 5 goes into 15 3 times. So 3 times the 1 that's there is 3x. Okay, nothing to distribute there. That's just the way it is. And then 5 goes into 15 3 times again. And 3 times that 2 is 6. And we'll go ahead and distribute in just a minute. So again, getting rid of the fractions, that's always the tricky part. I understand we don't like fractions. They make us nervous. Okay, so just there's going to be several problems with fractions on your homework. So now I'm going to distribute. That gives me 70x minus 35. Over here, I've got 3x plus 24 minus 18x. I'm going to collect those like terms that are on the right side of this. 3x minus 18x, that's negative 15 of them, plus 24. I'm going to get all of my x's on the left by adding the 15x over to this side right here. So when I add the 15x to both sides, I've got 85x. I'm now going to add the 35 to get all my numbers on the right. So when I add the 35 to both sides, I've got 59. And then the last thing I'm going to do is divide both sides by 85, and that gives me the x value of 59 on top, which I think is prime, so there's nothing I can do with that, over 85. 59 over 85. That's my solution set. A wild answer, but that's okay. Fractions are numbers too. All right, the other thing I just wanted to mention, and then we're just going to each do one more problem today to review one more thing, and that way you can at least get started on the homework for this, so that it's not so much to do next week. Just want to remind you about the one difference when you're solving an inequality versus an equation. Okay, process-wise, there's almost nothing different. Okay, so look at example 3. Example 3 is my example. So just like the equations, first thing I'm going to do is I'm going to distribute and collect those like terms. Okay, no difference at all. So on this problem, I've got 3x, then I've got negative 4x, and then negative 8 when I distribute is less than or equal to 2x plus 1. If I can just give you a little pointer here, do not make this an equal sign. Keep the inequality sign. I see over and over on the test students maybe trying to make things shorter, putting an equal sign here and then messing up the sign at the end. Okay, so please just keep the inequality sign, it matters. So collecting like terms, 3x minus 4x is negative x minus 8. Then I have 2x plus 1. So again, just like my equations, I'm going to put my x's on the left, my numbers on the right. So I'm going to put the x's on the left by subtracting this 2x. When I subtract 2x, how many x's do I now have on the left? What's my coefficient? Okay, negative 3x. I'm going to add the 8. When I add the 8, what is my number that's going to be on the right side? 9. And when you solve an equation, or excuse me, when you solve an inequality, adding and subtracting doesn't do anything to the sign. So I'm going to leave this less than or equal to. Now here's why I made my answer, my problem this particular way. What do I have to divide by now on both sides? What's the key word right there that you just said? Negative. What do you do when you multiply or divide by a negative, only a negative? Does anyone remember? Got to flip the sign. You do not do that with a positive. If you multiply or divide by a positive, you leave the inequality alone. It's only when you multiply or divide by a negative. So what that means is the answer here is going to be x. Since I divided by a negative, it becomes a greater than or equal to. And 9 divided by negative 3 is negative 3. And we always write our inequalities in interval notation because that's an infinite number of answers in my solution set there. So this is my x values are bigger than or equal to negative 3. So is negative 3 the lower bound of the interval or the upper bound? It's the lower. Everything is bigger than that. You can use a number line if that's not obvious to you. I understand. Okay, so use a number line like we did when we talked about interval notation. It's going to infinity. Always put a parenthesis at infinity. And on this problem, what do I put at the negative 3 end? A bracket because of the equality. All right, so last problem for you for the day, and then you're done with week 1. Congratulations. I'm going to give you about 2 minutes to make as much progress on exercise 4 as you can. And then I will join you and we'll finish it up. All right, so I'm just gonna get started. If you're still working, that's fine. I know you might not be done, okay? So there's no shame in that. I just want to make sure we're out on time, like I promised you. So first thing we're going to do is we're going to distribute, okay? So 6x plus 2 plus 10x. If you collected some like terms there, that's totally fine, but I'm just doing one thing at a time. So when I distribute, I have negative 4x minus 8 plus 10. Okay, so now what I'm going to do is I'm going to go ahead and collect those like terms and get a pen that will write. And so on the left side of this, 6x plus 10x is 16x plus 2. And then on the other side, I have negative 4x, and negative 8 plus 10 is plus 2. So far, are we so good? Bless you. I'm going to get my x's on the left, numbers on the right. So when I get the x's on the left, I add the 4x here, and that gives me 20x on the left. Adding and subtracting does not change my inequality, so it's still a greater than. When I subtract my 2, now here's why I put this example on here, because sometimes we get a little confounded when we see this number. When I subtract the 2 to get this 2 over to the right, what does my number on the right become? 0. 0 is a number. Okay? It's not undefined. Sometimes students write that. 0 is usually what I have in my wallet. Okay, so it is a number. All right, last thing I'm going to do is I'm going to divide by 20. And so we get x. What's the inequality sign going to be? Same, because I did not divide by a negative. I divide by a positive, so it stays greater. And then what's 0 divided into 20 parts? Still 0. Right. And now write that in interval notation. If all of my numbers, my x's, are bigger than 0, and if you graph that on a number line for visual, is 0 the lower end of the bound, or the lower end of the interval, or the upper end of the interval? It's the lower. 0 is the lowest. That means it goes to infinity. And I always put a parenthesis at infinity. And this time, what am I going to put at the 0 end? Not a bracket, because there's no equal on this one. It is a strict inequality. There's no equal.